Yes, good evening guys to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. So guys, this is the first session in the Formula 1 series, and in this Formula 1 series we are going to see all the formulas of the subject within 1 hour or 1 hour 10-15 minutes, not more than that. Chandra Buleshu, good evening. Hemang, good evening. Ajay, hi dear. So this is going to be a very quick revision session for theory of machines. Okay, and this is Formula 1 marathon series. This is the first session in that. Murli, yes. Good evening, Ajay and Murli. Good evening. So we are starting the session without wasting the time. So guys, this is some detail about me. My name is Dheeraj Sardana, 10 plus years of experience, and this subject is going to be theory of machines. And guys, before we start, I would like to tell you one important thing, that whatever these sessions are going on, to get the PDFs of these sessions, like today's morning mock test, then evening production practice session, then this Tom formula series, all these sessions you would be getting PDF on my Telegram channel, that is Mechanical by Dheeraj Sir, Mechanical by Dheeraj Sardana. Okay, so you will get PDF of the session, all exam notification, handwritten notes, previous year's question, doubt resolution, and all the important updates related to your paper. Okay, then my dear, you know that prediction series is going on. Today we have seen the first session of that, that is for production, and tomorrow we will be having the second session for Tom, where we will be discussing 10 top questions, 10 questions. Okay, and every day we have one subject. Okay, then my dear, Formula 1, this is the first session today related to Tom. So every day we will be having one session for one subject. Okay, so be ready for that as well. And guys, this is going to be 27th January, 28th and 29th for maths and aptitude and verbal ability. All things would be given by this trio. Okay, Yadam sir, what about production marathon? Yadam, for that I would like to tell you, tomorrow we have for material science. Okay, and tomorrow, if you guys will say, we will arrange for metal forming also on Tuesday, because for casting and welding already I have taken, for metal cutting already it have been happened, so we are left with only metrology, metal forming and sim. So tomorrow we will finalize. If you want, we can have that on Tuesday, and we will cover in that metal forming, computer integrated manufacturing and metrology. Okay, Chandra Buleshu, I will cover that as well. So just like and share the session guys, so that other students can also join it. So tomorrow we will be having the top 10 questions for Tom and vibration. Okay, so be ready for that as well. So tomorrow's session is going to be also very good. Now we are starting it. But guys, as I said, like in the complete marathon session, I have taught you everything in great detail. So that is why for Tom we are normally we have given around 15-16 hours at that time. So this is not going to be like that. This is going to be quick revision, like short notes, how you read it. Okay, this is like that. Vineet, I will share the complete schedule on the Telegram, and every day we are covering one subject. Okay, every day we are covering one subject. Yes, Kalyan, welcome to the session. So guys, whenever we are starting the theory of machine, we start with the simple mechanism. In the simple mechanism, the very first formula comes out for degree of freedom. You know, when we are writing degree of freedom for a link in the pair, then degree of freedom comes out to be 6 minus restraints. That is the formula for degree of freedom for 3D. For 2D case, it will become 3 minus R. Okay, you know that. Then you know, for 3 dimension, we have total degree of freedom to be 6, and for 2D, we will be having the total degree of freedom to be 3. That also you have seen. Then my dear, you know there is a Kurzbach equation. This is Kurzbach equation. F is equals to 3L minus 1 minus 2J minus H. Here L is number of link, J is number of joint, H is the number of higher pairs. And you know, then we have modified this equation for some of the cases. For that we are having minus FR, where FR are the redundant degrees of freedom. These are those motions in the mechanism which was not having any particular role, and because of that we are going to subtract it. Okay, so this equation was given the name of Kurzbach, and when you are having FR, it was said to be the modified Kurzbach equation. I feel everybody remember that. Okay. Then my dear, there is a concept of redundant link. So every important point is also mentioned. Redundant link was that extra link which, if present or not present in the mechanism, will not affect the relative motion between input and output motion, input and output link. Then my dear, degree of freedom, you already know it is calculated by removing such link. Okay, otherwise you would be getting the wrong answer, and that is the reason the parallelogram. That is the reason when we have studied parallelogram. This was the parallelogram, and if you have double parallelogram. So this double parallelogram, if you are going to use, even modified Kurzbach will not give you right answer, because this link is a redundant link. So that is why this is said to be the Kurzbach paradox. Okay, that is said to be the Kurzbach paradox. Is it clear? I feel from this slide you got an idea how we are going to cover each and every important point, each and every formula, and that is what is required at the final stage. Okay, then my dear, you have also seen the Grublers, very good Kalyan. Then you know the Grublers equation, which is given as 3 into L minus 1 minus 2J minus H is equals to F is equals to 1. You know higher pair is 0, then the equation will become 3L minus 2J minus 4. And what is the significance of this equation? This equation says that if you want a mechanism, with only binary joint, sorry, not binary joint, only with lower pairs. If you want a mechanism only with lower pairs, mechanism means degree of freedom should be 1. Lower pair means higher pair is 0. Then number of links should be even, and that even number is starting from 4. So you will get mechanism either by 4 link, 6 link, 8 link, 10 link. You will never be getting mechanism by 3 link, 5 link, 7 link, 9 link if you are not using any higher pair. Then my dear, you also know one higher pair is equivalent to 2 lower pair. So the work done by 2 lower pair can be done by 1 higher pair. Sir, J naught means only lower pair, sir? No. Dear, joints can be ternary also, joints can be quaternary also. Okay, joints can be ternary and quaternary, but it should be lower pair only. Okay, when you know that if we are going to have a ternary joint like this, so all these are lower pairs. Okay, so pairs should be lower, but this joint is ternary. That is feasible, you know that. Okay, Kalyan, I feel you understood what I want to say. Now moving to the Gresham's law. Yes. So that is higher pair. Kalyan, that is higher pair. For rolling, you will not be able to apply, that is Grublers. Grublers is applicable only for the cases when we are using lower pairs only. Okay, so we are talking about Gresham's law, and that is the reason when you are talking about cam and pullover mechanism, this is a mechanism. Still we are having only 3 number of links. If you see here, number of links are 3. With odd number of links we are getting mechanism because of this higher pair. So that is what I want to say. If you are having 0 higher pair and you are making the mechanism, means degree of freedom to be 1, the number of links should be even. That was the Grublers criteria. Kalyan, you got it? Please tell me that. Moving to the Gresham's law, my dear. Then my dear, you know, whenever we have a simple 4-bar mechanism, we are having some group of mechanism which we are getting by fixing a link of a kinematic chain. And if we have a mechanism with 4 links, then my dear, we can get maximum of 4 inversion. So number of inversion will be less than or equals to 4. So for simple 4-bar mechanism, when we are talking about the inversions, then my dear, there were 3 inversions only. For simple 4-bar mechanism, these 4 inversion was converted into 3 inversion. And what were those 3 inversion? They were double crank, they were crank rocker, and they were double rocker. And out of these 3 inversion, when we will be getting which type of inversion, for that Gresham have given a law. And Gresham said that you would be getting the continuous relative motion if you satisfy this condition, where S plus L less than equals to P plus Q. But my dear, if this condition is satisfied, he said I will be giving you continuous relative motion. For continuous relative motion, we can give a guarantee of a crank. So when we say continuous relative motion, it simply means that minimum one crank will be present. Ganesh, hi dear. It simply means that minimum one crank should be present. So it means he was giving guarantee that one crank would be there for sure. But my dear, when we have started this, how we need to check it, I told you. First we will see whether law is satisfied or not. If S plus L is less than P plus Q, or if you find S plus L is equals to P plus Q. For both these conditions, when all the links are having unequal length, for both the condition, what you will see, first of all, you will see law is satisfied or not. If law is satisfied, you will see the shortest link. If shortest link is present at the fixed position, you will get double crank. If shortest link is present at input or output, you will get crank rocker. If shortest link is present at coupler, you will get double rocker. So my dear, that is why whenever we are talking about this, you would be getting either double crank or crank rocker, but still you are getting double rocker. When you are getting double rocker, if shortest link is becoming the coupler. So for this condition, even though law is satisfied, still we are not getting a single crank. But you know, that is said to be the misutilization. Sir, if law is equal, which mechanism is applicable? Law is equal means law is satisfied. Are you saying, dear? You are saying if S plus L is less than P plus Q, or S plus L is equals to P plus Q. If these two conditions are there, then if shortest link is the fixed, you will get double crank. If shortest link is not fixed, then shortest link may be at input, may be at output. If that is the condition, you will be getting crank rocker. If shortest link neither fix, nor input, nor output, then it must be coupler. And if it is coupler, even though law satisfied, you will get double rocker. Even though law satisfied, you will get double rocker. I feel Chandra, Buleshu, you got it what I want to say. This, if you remember, you can solve the questions. But if we have one more condition that S plus L is equals to P plus Q, but shortest link and P are equal, longest link and Q are equal. It means we have four links S, S, L, L. So my dear, for that we got two configuration. One when shortest is joined with longest, longest is joined with shortest. This is said to be parallelogram. For this configuration, you know that all the time we will be getting double crank. Whatever be the link you are going to fix, we will get double crank. And similarly, when shortest are joined, longest are joined, S, S, L, L. Then also, my dear, you would be getting either double crank or crank rocker. For these two chains, we will never get double rocker. So that is why they are said to be the golden chains. And my dear, if you have S plus L to be more than P plus Q, then my dear, it will result into double rocker. So please tell me, guys, up to which whatever we have seen, everybody is clear about this or not? Then we are moving further. So this is going to be a very quick revision session, like you are revising just before the test. Okay, and this is wonderful one. I will say that. Next is the transmission angle. You know that when we are talking about the transmission angle is the angle between the output link and coupler. Okay, so if you remember, we need to find out the mu. For that, what we do, we are going to take a diagonal which is equals to k. Then we are going to apply the cosine rule. And what does cosine rule say actually? You will be having k square is equals to a square plus b square. If this side is a, this side is b, this side is c, this side is d. Then a square plus b square minus 2ab cos theta. Similarly, you can write k square is equals to c square plus d square minus 2cd cos mu. Then my dear, you need to find out the minimum and maximum value of the transmission angle. So my dear, you will be getting minimum transmission angle for theta to be 0. and you will be getting maximum transmission angle for theta to be pi. But this you will get when? For this condition, this is possible only for crank rocker mechanism. For crank rocker mechanism. For crank rocker mechanism. But if your mechanism is not crank rocker, if your mechanism is double rocker, if your mechanism is double rocker, then my dear, you would be getting transmission angle to be minimum and maximum for two conditions. What are those conditions? One is theta 0, which will be possible. Second is beta 180 degree. Okay. So this would be the condition. This would be the condition. Like if this is the link, this is another link. This would be the condition for which I am talking about. So at that time, this angle will become 180 degree. Okay. Because when it is double rocker, you will never get theta to be 180 degree. Okay. So for such case, you will be using this. I feel we have done many times numerical onto this, so everybody would be getting it properly. Okay, Vineet, you are clear? Not for double crank. For double crank, every value will be possible. We are talking either for crank rocker or for double rocker. Okay, we are talking about only for these two configurations. And you know that why we study this? Actually, what is our requirement? We need that transmission angle should be near to 90. Because if transmission angle will be deviating more from 90 degree, then my dear, output torque would be affecting. And if output torque would be affecting, my dear, maybe the motion of output torque will not be possible if transmission angle is becoming 45 degree or deviating more than that. So that is why we always want transmission angle to be near to the 90 degree. So the value, the ranges of transmission angle are also said to be the quality of a 4-bar mechanism. Okay. So my dear, that is why if mu is near to 90, it is said to be a good quality mechanism. Otherwise, it is a poor quality mechanism. I feel everybody remember it. This is a very good revision for those students who have already studied the subject. They just want it quickly. Now, my dear, we are talking about the quick return motion mechanisms. So you know that beta is the cutting stroke, alpha is the return stroke. Alpha plus beta is 360. Then quick return ratio is defined as time of forward by time of return, velocity of return by velocity of forward, beta by alpha, 360 minus alpha by alpha. It is always more than 1. Then my dear, stroke length for the Whitworth mechanism is given as R1, R2. This is 2 times the diameter of smaller circle. Okay, 2 times the diameter of smaller circle. Or you can say, not 2 times diameter, 2 times the radius. Okay, 2 times the radius of the smaller circle. So you can say the dia of smaller circle. Dia of smaller circle is nothing but the stroke length. Okay, so my dear, you can see this is C1, this is C2. So this diameter is equals to the stroke length. That also we have seen. Vineet, are you clear? Please tell me that. Are you clear? Next is crank and slotted lever. You know that the first quick return motion mechanism which came into picture was nothing but Whitworth. But right now we are using crank and slotted lever. Why? Because in Whitworth, stroke length was equals to the dia of smaller circle. So my dear, if you want to increase the stroke length, you need to increase the diameter of smaller circle. If smaller circle dia will increase, the big circle diameter will also increase. And if all the dimensions will increase, the mechanism will be bigger in size. We don't want that kind of big size, okay, because otherwise size restrictions would be there. So my dear, in crank and slotted lever, we are having an improvement. In crank and slotted lever, stroke length is given by 2 into crank length into length of slotted lever bar and divided by connecting rod length. So somewhere it is 2 into R into slotted bar length divided by L. So it is depending on 3 parameters. And my dear, if 3 parameters are there, then my dear, there is no load on single parameter. Even by reducing the connecting rod length, you can increase the stroke length. So there are 3 parameters. So definitely this time in the smaller size, we will be able to manage the things. Yes. Is it clear? Is it clear? Yes. Sir, formula for area swept. Okay. Formula for area swept also I will give you. you know that area swept will be like this. Area swept by slotted bar will be like this. And you also know that this angle is 180 minus alpha. Sorry, this is 90 minus alpha by 2. This angle is 90 minus alpha by 2. If you see double of that, then it will be 180 minus alpha. So this angle I am saying as gamma. Gamma is 180 minus alpha. So if you want to find out the area swept, it would be given as pi slotted bar length ka square into gamma by 360 degree. This is how we can find out the area swept by the slotted bar. Is it clear for everyone? Do like and share the session, guys. Like the session, because in 1 hour we are going to revise the entire topic. Yes. Ha, Kalyan. Here we are having, in Whitworth, we are having crank of single slider crank mechanism to be fixed. For single slider crank mechanism, the number of inversions are 4. Whereas for simple 4-bar mechanism, number of inversions were 3. Okay. And here, my dear, we are getting it when we are fixing the connecting rod. So as this is formula revision, so guys, here only formulas wale topic hi hai. Okay. So my dear, that is why you are only able to see the formulas. Now my dear, it is talking about the number of eye center. Okay, one more formula I would like to give you. The sliding velocity for Oldham's coupling. That is also one of the question. This is D, which is offset, into omega of driver. This is the sliding velocity for Oldham's coupling. Now my dear, we are talking about number of eye centers. Okay. So when I was teaching you in the marathon, I have taught you entire thing. But here we are having the formulas only. So for number of eye center formula, you know that the number of eye center is given as NC2. That is equals to, if number of links are N, that this is the formula. At that time I have denoted it with L. So you can also write L into L minus 1 by 2. Or you can also write it as L into L minus 1 by 2 factorial. Okay. So this is how we can define. This is how we can define. Yes, Kalyan, don't worry. We will be having mechanical advantage also. Okay, I feel we are having the mechanical advantage. Don't worry. Okay. We are having the mechanical advantage. Don't worry. Dear, this was the formula for Oldham coupling. D offset into omega. Okay. This was the formula for, yes, this was the formula for Oldham coupling. Now we are having the theorem of angular velocity. So you know that when we are talking about theorem of angular velocity, the formula is omega m I mn I1m. Omega n I mn I1n. You know, according to the Kennedy's theorem, if we have 3 links M, N and P, then you know, for relative motion between these 3 links, we would be having 3 eye center for them, Mn, Np and Pm. So all these 3 eye center must lie in a straight line. This is the Kennedy theorem. They must lie in a straight line. So my dear, if they are going to lie in a straight line, then only there will be any relative motion between the 3 links. Sure money, I will be sharing. I have shared the morning PDF also. I have shared the production PDF also. This also will be shared to you. Don't worry. So guys, if you see this, if you see this, if you see this, so you get to know that all these 3 eye centers should be lying in a same line. So here also, my dear, when we have link number 1, link number M, link number N, we would be having 3 eye centers, 1M, 1N and Mn. All 3 eye center would be in a straight line. But my dear, their positions can be like this. One position is if Mn is here, 1M is here, 1N is here. So if 1M and 1N are on the opposite side of Mn, then my dear, for this case, omega M and omega N will be opposite in direction. Okay, will be opposite in sense of rotation. But on the other hand, if we have this point to be Mn, this point to be 1m and this point to be 1n. Means 1m and 1n are on the same side. For that case, we can say omega m and omega n, they will be having the same sense of rotation. They will be having the same sense of rotation. I feel everybody is getting. Okay. Good evening, Umar. Good evening, Umar. So dear, we are moving further now. Now we are talking about the relative velocity approach. You know that in relative velocity approach, what we said, if we are going to write down velocity of B with respect to A, it is perpendicular to link AB in sense of omega. And we were writing it as AB into omega AB. This was the relative velocity approach. Everybody would be remembering it. Okay. Moving further, guys. So I would also like to add one more thing in the relative velocity approach. If you remember, when we are having two links parallel to each other, and let us say this is OA, BC. If they are parallel to each other, if I am saying OA is parallel to BC, so for this case, we can write velocity of AO is equals to velocity of BC. And using this, we can find out the angular velocity of output if for input it is already given to us. Very good, Kalyan. So this is the first case. And you are also remembering, you would also be remembering when we have studied crank and slotted lever mechanism. For crank and slotted lever mechanism, you would be remembering if we have the slotted bar, link number slotted bar, you want to find out the slotted bar velocity, that is the maximum during forward stroke. Then you can write R divided by L plus R. R divided by L plus R into omega of crank. This is during forward stroke. For return stroke, the same slotted bar velocity maximum would happen at R divided by L minus R into omega crank. I have derived all these things at the time of marathon. Okay. So right now, that is why just quickly I am writing the formula. Now you must be in a position, if you are given a open page, a free page, you are able to write every formula with the sequence. Okay. That should be the position now. That should be the condition now. Now we are talking about the acceleration analysis. You know that when we are talking about acceleration, I have a doubt even they are not 90 degree with input. Ajay, if they are parallel, the velocities are going to be same. Even then angle is 90, not 90 degree. If they are parallel, the velocities will be same. Okay. So let us move further. Now we are talking about acceleration analysis. So my dear, for acceleration analysis, if something is in rotation, you know, even if rotation is happening at constant velocity, then also my dear, the magnitude and direction, there are two things. So even if something is moving in circular motion or rotation, you must be aware of one thing, that direction of velocity is changing at every instant. Okay. So there is a component of acceleration which is responsible for this change of direction, that is said to be the centripetal acceleration. And centripetal acceleration is given as omega square into R or V square divided by R. If a body would be given this centripetal acceleration, only then this circular motion or rotation motion will be possible. Otherwise, it would not be possible. Okay, that is the point. So this is why there would be a component of acceleration that is said to be radial or centripetal acceleration. This radial or centripetal acceleration is responsible for change of direction of the speed. So it is change of direction responsible for that. It is always acting towards the center of rotation. Always acting towards center of rotation. Okay, towards center of rotation. Then we have a tangential acceleration. Tangential acceleration, my dear, if tangential acceleration will be coming if alpha is there, like if you are given the alpha in this direction, then there would be a component of acceleration, that is a tangential, and this tangential acceleration is given as r into alpha. This will have a tendency to increase or decrease the magnitude of velocity. So if you see all the times there are two acceleration, one is radial, other is tangential. So tangential would be in the sense of alpha. So when we say tangential, it is change in magnitude of velocity and direction is perpendicular to the radial acceleration. So if radial and tangential acceleration are perpendicular to each other, always the resultant would be given by this. So resultant would be always given by this. But mind it, radial is always towards the center of rotation. Tangential may be like this, maybe like this. That will be depending on whether alpha is given in this direction in the sense of omega or opposite to the sense of omega. If it is in the sense of omega, it will increase the speed. If it is opposite to that, it will decrease the speed. Okay. So my dear, if I say that there is a body which is rotating like this, if this is omega and this is alpha, then my dear, this would be tangential. Okay. And if that body is rotating like this omega but alpha is this way, then tangential will be this way. So tangential always follow the sense of rotation of alpha. Tangential is always perpendicular to the link length in the sense of alpha. So I feel everybody got it. Yes or no? Shall we move on, guys? Yes. So these are the two acceleration. Now we are talking about the third acceleration. The third acceleration is related to the Coriolis component of acceleration. So when we are talking about the Coriolis component of acceleration, you know this acceleration, whenever it comes, I generally ask, is it real or imaginary? I ask you, is it real or imaginary? Then if you remember, I told you this is a real acceleration, not imaginary. But why students are thinking it to be imaginary? Because it does not comes always in the picture. Yes, it is real one. Umar, very good. It comes in very special situation. Very good Kalyan, very good Shreyas, very good Umar, Vineet, Chandra Buleshu. It comes in very special situation. When this acceleration comes into picture, my dear, this acceleration comes into picture only when a body is sliding on a body. This slider is sliding on a body which already is in rotation. If omega of this is 0, there is no Coriolis. So Coriolis will come if slider is sliding on a body, the body is already in rotation. So slider is sliding on a body which is already in rotation, then only Coriolis will come into picture. Yes, very good Ajay. And that is there in crank and slotted lever mechanism, that is there in Whitworth quick return motion mechanism, that is there in rotary IC engine. So there are many places where such type of acceleration will be working. So now can I ask you, for a crank and slotted lever mechanism, how many time it will become 0? How many time the Coriolis component will become 0? How many time will the Coriolis component will become 0? How many times Coriolis component will become equals to 0? How many times Coriolis component will become equals to 0? Can you tell me how many times Coriolis component will become equals to 0? 4 times. 4 times. One, when slotted bar is in this extreme position. Second, when slotted bar is in this extreme position. Because at this condition omega will be 0, at this condition omega will be 0. These are the first two conditions. What are the next two conditions? Next two conditions are when the slider will be reaching to this position. At that time slider will be having velocity only in this direction. And the second position is this. So for these two positions, velocity of sliding will become 0. So 4 times. I don't know why you are saying 3 times. When I taught you so much number of times, from where you are learning this wrong concept, I don't know. In the classes I taught you 4 times, in the marathon I taught you 4 times. How you are saying 3 times? I don't get that. Okay, this is the 4 times. 4 times Coriolis will become equals to 0. Okay, and if normally you want to ask what would be the condition, if normally you would be asking what would be the condition, then for normally at any time, if the slider is at this position, so you know there are two velocities. One is along the sliding, and second is going to be perpendicular to the, second is going to be perpendicular component. So there are two components of the velocity. One is perpendicular to slotted bar, other is parallel to slotted bar. Is it clear now? Is it clear now for everyone? Shall we move on? Everybody understood this? Yes. So everybody understood this? Yes. So guys, now the point is, what would be the direction of Coriolis component? So my dear, if you want to see the direction of Coriolis component, you need to see first of all that it is always acting on the slider. So you will see sliding velocity is in this direction and omega is in this sense of rotation. So omega is clockwise. So you just imagine a clock, put the velocity vector on the clock. You can see the time is 12. If omega is rotating clockwise, you rotate this by 90 degree in the clockwise. It will be showing you this 3 p.m. will be the time. So the Coriolis will be acting in this direction. So for getting the direction of Coriolis, just rotate the velocity vector of slider by 90 degree in the sense of rotation of omega. We are not rotating in this direction. We are rotating in clockwise because this is clockwise. So don't see this direction. Always see the sense of rotation. If sense of rotation is clockwise, it would be rotated by 90 degree in the clockwise sense of rotation. Very good, Kalyan. Any doubt, guys? Do ask me. Do not do such type of silly mistake and just lose your marks. Then, my dear, this is Clint's construction. If you remember, this was given for single slider crank mechanism. And in this construction, they have made the velocity and acceleration diagram. To plot the velocity diagram, they just extended the connecting rod length and put a perpendicular on the line of stroke. And this triangle OAP, this triangle OAP is nothing but the velocity triangle. And in this velocity triangle, we can also say one thing, that it is oriented by 90 degree and scale factor of omega. So you can write it VA by OA, VB by OP, VAB by AP is equals to omega of crank. And this is valid only for the mechanism for which alpha of crank is going to be 0, for which angular acceleration of crank will be 0. Only for those it is going to be valid. Okay, I feel everybody got it. I feel everybody got it. Now we are talking about the acceleration polygon. So when we are talking about acceleration polygon, for what we are going to do? First of all, we will be taking this AP as radius and plot a circle like this. Why? Because you know, for radial acceleration, we need the velocity diagram. So that is how we are using the velocity diagram for radial acceleration. And then you will be taking AB as diameter and plot another circle. Then, my dear, these two circles will cut at 2 points. You will join them and extend it to line of stroke. Then after this extension, you are getting a polygon, a quadrilateral. So this quadrilateral ARSO, this quadrilateral is nothing but acceleration diagram with a orientation of 180 degree and scale factor of omega square. You can see this component is telling you the radial component of acceleration of crank. This is telling you the radial component of acceleration of connecting rod. This is tangential component of acceleration of connecting rod. This is acceleration of slider. And you can write them as AA by OA, A radial by AR, A tangential by RS, AB by OS is omega square. Because here scale factor is omega square. Their scale factor was omega. Yes. This was given for single slider crank mechanism, my dear. So obviously it would be valid for that only. Okay. Is it clear for everyone? So this is the velocity and acceleration analysis going on. Moving further now, Kalyan, you were asking about mechanical advantage. Here is the mechanical advantage. So my dear, mechanical advantage is defined as force output by force input or torque output by torque input. Efficiency is power output by power input. Power is torque into omega. So my dear, we can write mechanical advantage as efficiency times omega output by omega input. So you can also write down mechanical advantage as efficiency times omega output by omega input. Okay. Is it correct? I feel it is wrong. It is opposite. Omega input by omega output. Okay. Just write from this. You can write torque output by torque input, which is mechanical advantage. Okay, then it would be coming out to be equals to efficiency times omega input by omega output. Okay, so it would be omega input by omega output. This is the correct formula. So that is why whenever output link, whenever a link is changing its direction of motion, whenever a link is changing its direction of motion, at that condition you are going to have omega output to be 0. When omega output is becoming 0, mechanical advantage is becoming infinity. So all such position where we are getting mechanical advantage to be infinity, they are given the name of toggle positions. They are given the name of toggle positions. So my dear, toggle positions are those at which the output link is changing the direction of motion. So that we have also seen with toggle mechanism. So toggle mechanism, I feel everybody would be remembering. This is said to be the toggle mechanism. This is also said to be the snap action mechanism. Everybody remember it or not? Please tell me that. This is the toggle mechanism. This angle is alpha, this angle is alpha. When alpha tends to 0, slider will be at its extreme. It will be changing direction of motion. So velocity at that instant will be 0. Because of that, you will be getting mechanical advantage of infinity. So whatever be the force you are giving as input, here is going to be infinity, means lakhs, kai guna ho jayega force, lakhs of Newton. So that is why this mechanism is used for stone crushers. Yes, very good, Kalyan. Moving further, guys. So we are entering into the next chapter, that is gear. I already told you. Yes, very good, Manas. I already told you, like we are going here for revision of formulas only. So whatever we have covered on that day in 8-9 hours, today we have covered in 40 minutes. That is how the things are going on, because this is formula revision. Now my dear, for gear terminology, before we discuss it, you already know in gears are the positive drives, belt drive, chain drive are the negative drives. Gear are said to be positive drives because in the gear we are saying there is no slip. Okay, because no slip will provide you the constant omega ratio. Okay, constant omega driven, constant omega ratio. So constant omega ratio is possible only with the gears. It cannot be possible with the belt drive, rope drive, chain drive. Okay, that is the reason. Yes, Abhishek, good evening dear, how are you? So guys, whenever we are going to see this gear terminology, I feel everybody is aware that there is one circle said to be the addendum circle. There is another circle said to be dedendum circle. Dedendum circle is not base circle, it is root circle. Then we are having a clearance circle. Then we are having a pitch circle. Pitch circle is very, very important because all the dimensions are measured from the pitch circle. You know, the distance of addendum to the pitch circle is addendum. Dedendum to the pitch circle is dedendum. Okay, the thickness along the pitch circle is tooth thickness. The gap along it is tooth space. Okay, then you also know that the total tooth space and tooth thickness is said to be circular pitch. And my dear, you also know circular pitch is defined as the circumference divided by number of teeth. Okay, then you also know module is defined as diameter by number of teeth. Then diametral pitch is given as T divided by D. You also know the product of circular pitch and diametral pitch is pi. This is asked in GATE 1991. Is it clear for everyone or not? Liking this fast revision or not? Please tell me that. So we already defined circular pitch is pi d by T. Then module is D by T. Diametral pitch is T by D. Here D is in inches. Here D is in mm. That is the difference. Gear ratio is always, remember, it is always more than 1. It is always defined the number of teeth in gear to the number of teeth in pinion. Always remember this. This is gear ratio. It is always coming out to be more than 1. Yes, very good, Kalyan. Bahut hi badhiya. Guys, do like and share the session. Then we are going to have one more formula, that is speed ratio or velocity ratio. For speed ratio, do not see this formula I am writing. Speed ratio is omega of driver to the omega of driven. Okay, then we have train value. Train value is omega of driven to the omega of driver. Train value is 1 upon speed ratio. Very good, guys. Very good, Kalyan. Very good, everyone. Then, my dear, we are also having something known as contact ratio. Contact ratio is defined as arc of contact by circular pitch. Arc of contact by circular pitch. Arc of contact by circular pitch. And my dear, when we are talking about arc of contact is given as path of contact by cos phi. So guys, now it is not marathon session where I am going to define what is the pressure angle. So if you have any doubt, you ask me, I will tell you. I feel everybody would be aware of that. Still, I am telling you, if you want, whenever two gears are mating here, their pitch circles are always in contact, because that we have already studied in the marathon. So their pitch circles are always in contact. Okay, their pitch circles are always in contact. This is the line joining their centers. And my dear, if we are going to plot a tangent onto this both pitch circles, this is said to be the common tangent. This is said to be the common tangent. Now, you know, when two gears are mating with each other, obviously one gear is going to rotate the other. So one gear is going to rotate the other. For that, it is going to apply some force. And the line on which the force is applied, this is said to be line of action. And this line is always perpendicular to the profile. And this is also said to be the line of action or common normal to the involute, or common normal to the teeth profile. Okay, to the teeth profile. So my dear, now if you are going to make this line of action here, this is making an angle of phi with the common tangent, which is said to be pressure angle. So because of this, this is the line along which force is transmitting. So its horizontal component is responsible for rotation of gear, and vertical component will be going on to the bearings. So Ft is given as F cos phi and this is given as F sin phi. I feel everybody remember that. सर गियर समझने में, हाँ गियर समझाने में आपको मैंने 10 घंटे लिए थे. Okay, but here we cannot give that. Okay, this is the revision. So in the course class, you must have seen I have taken 10 to 12 years to make you understand what is involute, what is cycloidal. Okay, so here we are just having formula revision. So arc of contact is path of contact by cos phi. Then my dear, you already know contact ratio is arc of contact by circular pitch. Then my dear, what is path of contact? Path of contact is made up of two things. Path of contact is made up of two things. One is path of approach, other is path of recess. Other is path of recess. So you can see path of approach is given by this, path of recess is given by this. This capital R denotes the gear, small r denotes the pinion. I feel everybody understood that. I feel everybody understood that. Yes, Abhishek, Kalyan, Umar, Vineet, everybody is getting it. Yes. And you also have seen that when we are going to apply the property of involute, involute was defined like if we have a fixed circle and if we have a line, if this line is having pure rolling motion onto this fixed circle, then the locus of any point onto that will give you involute. And you know that this tangent to this circle is the fixed circle, and this was given the name of base circle. So you get to know that tangent to the base circle was perpendicular to the involute profile, but perpendicular to involute profile is the line of action. Line of action and tangent to the base circle are the same things. So we get to know for two gears we will be having two base circles. If we have two base circle, then my dear, we need to have one common tangent to both the base circles. If we have one common tangent to both the base circle, it means we can have only one line of action. But line of action is plotted at the point of gear teeth profile. Gear teeth profile, when we are talking about, it has infinite points. So my dear, when we get to know for a gear teeth profile, we are having infinite point onto that. But for infinite point, we can have infinite line of actions. But we get to know that line of action can be only one. It means all the point of contact will be, all the contact point will be lying on this line only. So this is KP path of approach, PL path of recess. So that is how we have calculated KP and PL, and this is our path of contact. And during this path of contact, whatever the gear and pinion rotates, that is the arc of contact. And arc of contact is divided by the circular pitch will give you the contact ratio. Contact ratio tells us how many pairs are in contact. If contact ratio is coming out to be 1.21, it means for 21% of the time 2 pairs were in contact. All these discussions we have made, I feel everybody would be knowing that, remembering that. Okay. Then my dear, you know, interference is a very big problem in the gears. And when we are having interference as a very, very big problem in the gears, so we have seen that interference was resulting into undercutting. So because of that, we get to know that we need to remove it. And we cannot reduce it only, we have to remove it. Without removal, we cannot even start manufacturing the gears. So if we want to make the gears, the first requirement is there should not be any interference. And if you want there should not be any interference, we have seen a number of methods. Do anybody remember the methods? Yes, Abhishek, Umar, Vineet. The first method was do the undercutting. Because we know gears will do the undercutting. If we do the undercutting before, there would not be any interference. But by doing so, the strength of gear was getting reduced. So this is valid for slow speed applications. Second was increase the phi pressure angle. But when we were increasing the pressure angle, you know that tangential force was reducing, torque was reducing, that was causing a problem. Very good. Third method was stubbing the teeth. Stubbing the teeth was a good option, but that was affecting the contact ratio. So that is why we cannot go entirely on that. Last was increase the number of teeth. Increase the number of teeth. This was the best method and alone can help you. So my dear, that is why this is the best method, but we are not totally relying on that. Because if you are going to increase the number of teeth, it will increase the cost. Because you know, in gears, manufacturing to the material cost is very, very high. So because of that, we cannot go for any number of teeth. Definitely, if we can avoid interference with 30 teeth, then going for 32 teeth is useless. It is going to be wastage of money. So that is why we need to know what should be the minimum number of teeth for which interference will not happen. So that we have derived. For pinion, this was the formula. For gear, this is the formula. You already know here G is the gear ratio, which is number of teeth. I am showing the number of teeth by Z. Number of teeth of the gear or number of teeth of the pinion. You can also show it as TG by TP. Both are same only. This is the gear ratio. Phi is the pressure angle. What is AP? AP is the fractional addendum. Fractional addendum. It is said to be the fractional addendum. What is fractional addendum? What is fractional addendum? When you are going to write addendum is equals to module times of fractional addendum, then my dear, you can find out the fractional addendum is addendum per unit of module. Okay. This is how we are going to define the fractional addendum. This is AP for pinion, AG is defined for the gears. Is it clear, guys? So just like and share the session, guys. We are moving to the gear trains. We have seen all the formulas of the gears. Now when we are talking about the gear train, we already have seen the train value. We already have seen the speed ratio. So we already know module is D by T. We already know omega 1 by omega 2 should be equals to R2 by R1. So you know that for mating gears, modules are always equal, circular pitches are always equal. So we can write it as D1 by T1 is equals to D2 by T2. So we can write from here as D1 by D2 is equals to T1 by T2. So the ratio of diameter and teeth are always same. So we can write omega 1 by omega 2 as T2 by T1. But my dear, always remember, we will be keeping plus minus. Minus sign is coming if external gearing is there. Plus sign is coming if internal gearing is there. Why? Because in external gearing, driver and driven are rotated with opposite directions. And in case of internal, they are moving in the same directions. Sir, if gear is safe, then automatically pinion also safe, na sir? Dear, I would like to say you are saying opposite. Generally, if both gear and pinion are made up of same material, then pinion is on the weaker side. So first we will design the pinion, we will make it safe. Then according to the gear ratio, you will get the size of gear. Because force, whatever the pinion is applying on the gear, the same is gear applying on the pinion. So if pinion is safe, then we can say gear will be safe. Okay. So design of pinion is becoming important because pinion is generally on the weaker side. Because you know the material in the pinion is lesser than the gear. Okay. Got it? Umar? Great. बहुत बढ़िया. बहुत ही बढ़िया. So guys, now when we are talking about simple gear train, a gear train is said to be simple if every shaft is having only one gear. And my dear, you know that if every shaft is having only one gear like this, then if you are having the first gear as the driver and fifth gear as the driven, then other gears, this is gear number 2, gear number 3, gear number 4, they will just cover the center distance. They will not be distributing, they will not be contributing to the speed ratio. For this case, if you will find out omega 1 by omega 5, it will be coming out to be T5 by T1. And even if you would be having only this and this gear, then also the answer will be same. Means these three gears are useless, not useless. They are covering the center distance, because if one gear is here, other gear is here, then you need to cover this distance. So that purpose is solved. If this is rotating in anti-clockwise, this is rotating in clockwise. This is in anti-clockwise, this is in clockwise, this is in anti-clockwise. Okay. So my dear, this number of these gears also will decide whether the output gear will rotate clockwise or anti-clockwise. Like for this anti-clockwise, we got this also anti-clockwise, because the number of intermediate gears were odd. So if the number of intermediate gears would be even, then I would be getting clockwise to anti-clockwise, anti-clockwise to clockwise. So they can also help you to provide the desired sense of rotation. But my dear, in the speed ratio, their contribution is 0. So that is why all those intermediate gears which do not contribute to the speed ratio, they are given the name of idler. They are given the name of idler. So first thing, when you are going to decide idler, the first thing related to idler is that idlers are the intermediate gears. And second thing, they are those intermediate gears which do not contribute in the speed ratio. And my dear, what is the identification of such gear? If any intermediate gear is present alone on a shaft, it will act like an idler. Okay. So my dear, in simple gear train, all intermediate gears are idler. Is it clear? So guys, just like the session, share the session. We are moving with gears. This is the third topic. We are going to cover everything like that. Okay. It would be a very good revision session. Then we are talking about the compound gear train. So my dear, if any of the shaft is consisting more than one gear, then my dear, it is said to be compound gear train. Like if in this gear train, you can see there is 1, 2, 3, 4, 5, 6 gears, out of which this gear number 2 and 3, 4 and 5, they are present 2 gears on a shaft. It is not necessary that all intermediate gears should be like this. Even if we have this connection, this is driver, this is driver. Even if we have this connection, this is also said to be compound. Even if you join this, then also it is compound. So for compound, even if one shaft is having 2 gears, all other shafts are having 1 gear, then also it would be said to be what? Compound gear train. Yes, Akhil, welcome to the session. I feel Akhil is also saying something. train is driver by driven, R comes first, then so it will be okay. Okay, Akhil, fine. So guys, yes, 1 hour complete, still we have 5 chapter. Don't worry, Kalyan, we will complete it fastly. Don't worry. Okay. So my dear, when we are talking about this compound gear train, so in compound gear train, if you see, this is gear 1, this is 2, this is 3, this is 4, 5 and 6. So here these gears, you can see that. Don't see this formula. I am writing the formula for this. Okay. So when we are talking, we are talking about the speed ratio. Yes, thanks Akhil for that. So Akhil sir is giving a trick for your help. So my dear, when we are talking about this speed ratio, for such case, for compound gear train, it is defined as the product of number of teeths. The product on number of teeths on driven divided by product of number of teeth on driver. So my dear, if you see in this case, gear 1 is rotating because this shaft is given some speed. So gear 1 is acting like a driver. Gear 1 is acting like a driver. Gear 2 is rotated because of gear 1. So gear 2 is acting like a driven. Then my dear, the third one is rotating because it is present on the same shaft on which gear 2 is present. So gear 2 is rotating that shaft, because of which that will also be rotating. So my dear, because of this, this gear 3 will also be acting like the driver. And 4 is rotated by the third gear, so it would be driven. Similarly, 5th will be driver and 6th will be driven. You can say all those gears which are rotated by others, they can be treated as the driven gear. This is the trick. If you will use it, you will get the right answer. So my dear, I can directly write the speed ratio as omega 1 divided by omega 6 will be T2, T4, T6, T1, T3, T5. This will be the formula for the speed ratio. Now my dear, you can see here every gear is participating. Every gear is participating in the speed ratio. It means none of the gear is idler. This time these intermediate gears are not idlers. They are not idlers. So always remember how we are going to choose the idlers. If you see this is gear number 1, gear number 2, gear number 3, gear number 4, gear number 5. For this case, how you will write omega 1 by omega 5. If you see, it looks like 2 is driven. It looks like 4 is driven. But here 5 is also driven by the gear, so I will write T5. But 1 is driver. 1 is driving the second. Third is driving the fourth one. And fourth one is driving the fifth one. So T4 will be also coming. So you know T4 will get cancelled out and you will be getting T2, T5 by T1, T3. So if you will be following my rule, you will be getting the correct answer automatically. Is it clear? Yes. This session is an audio book for the formula revision. Wonderful, guys. Moving further. Now we are talking about the reverted gear train. Reverted gear train, my dear, is used whenever we have same axis of rotation for driver and the driven. So you can see in the given figure, for driver and driven, we are having the same axis. Okay. So my dear, if you see this on this one shaft, okay, I will make my own diagram. This is the axis. This is the axis for driver shaft and this is the driven shaft. Both have the same axis of rotation. So if I have one gear on it, another gear on it, then my dear, how to transmit the power? We will be having one more shaft. And on this shaft, we will keep one gear like this and another gear like this. So my dear, the power will be transmitting from this to this, this to this, this to this. So if you see gear 1, gear 2, gear 3 and gear 4, 2 and 3 are on the same shaft. So as gear 2 and 3 are on the same shaft, my dear, because of that, it will also come in the category of compound gear train. It will also come in the category of compound gear train. So you can apply the same formula here also. But here sometimes they do not give you the number of teeth of all the 4 gears. For that you can go for the equating of center distance. If you see this axis and this axis, this center distance is R1, this is R2, this is R3, this is R4. So you can write R1 plus R2, R3 plus R4. Now module is d by t. So you can write module is 2 times of radius by number of teeth. Radius can be written as mt by 2. So you can use the radius as mt by 2, and you know they will be giving you the module relation, or they will say all the modules are same. So my dear, just putting these values of radii, you can find out the unknown number of teeth. Very good, Kalyan. Moving further, guys. Moving further. Next is planetary gear train. So if you remember, this is the type of gear train for which the axis of one gear is rotating. Axis of one gear is rotating. For this, the degree of freedom is coming out to be 2. For epicyclic gear trains and for planetary gear train, we have a tabular method like this. And in this tabular method, in the first step, we fix the arm. We give one rotation to one gear and we see the second gear. And my dears, for the second case, we will give arm to be 0 and X rotation to the one gear, and we see the rotation of the second gear. And for the third case, we give Y rotation to the arm as well. And then overall we are getting the three things. This is the speed of arm. So speed of arm we are getting as Y. Speed of gear A you are getting as X plus Y. Okay, just wait. Okay. Everybody remember this table? Sure, Umar, sure, Umar. Is it clear up to this? Please tell me that. Then we are moving further. So guys, do like and share the session. Then we are moving further. So you know that for arm, this is the rotation, N of arm. For N of sun gear, it is X plus Y. For N of planet gear, we will call this as sun, this as planet, because this rotate about the sun. This is minus X times TS by TP plus Y. Now you can see in these three, there are two things unknown, X and Y. So in these three, yes, Umar, in these three, there are two things which are unknown. So for that, in the question, you will be given two things. He will be saying, out of these three, arm, P and sun, out of these three, one gear would be fixed. And for other, they will be giving you the speed. So you just need to put the two values in these three equations. You will be getting X and Y. And once you will get X and Y, you can answer the speed of sun, the speed of planet, the speed of arm. Everything can be given. Thanks, Umar, for that. So please tell, without table, we will do epicyclic sun. Yes, definitely you can do with algebraic method. What is the algebraic method for that? I will tell you. So my dear, algebraic method says that, you know that this sun and planet are mating gears and they are connected with the arm. So you can write omega sun minus omega arm, omega planet minus omega arm is equals to minus TP by TS. Minus sign is coming because of external gearing. Is it clear? Is it clear? Kalyan, understood? Kalyan, understood? Please tell me that. Great. That is nice. You can go with that as well. So I can tell you both the ways. The choice will be yours. Okay, I feel one more thing I need to tell you here. Like line diagram you are asking, na? Okay, let me add one extra slide for that. Okay, let me add one extra slide for that. For this, okay. So you are saying about the line diagram. So my dear, when we are talking about the line diagram is very, very important. If you see this is the notation for external gear. Okay, this is the complete external gear. Then half external gear is given like this. Half external gear. Why half? Because rest half will be coming here like this. So this is half up, half down. It can also be shown like this. Ring gear is shown like this. This is half ring gear. Half ring or annular gear. Then how arm is given? This is how the arm is given. This is the rotation of arm. Everybody got it? So if I show you a diagram like this, if I show you a diagram like this, then I feel you understood. I feel you understood this diagram. So let us see what this diagram is saying. This is ring. This is external complete. This is arm. This is external complete. This is external half. Everybody understood or not? Please tell me that. Very good, very good, very good. So this was to give you an idea how they can be shown by the line diagrams. Okay, that is something you will not get everywhere. Now my dear, we also can see one more thing if you want. That is the concept of fixing torque. That is the concept of fixing torque. Let us see the concept of fixing torque. Okay, so for that also, if you want to go for concept of fixing torque, if you see when we are talking about concept of fixing torque, for concept of fixing torque, you know that we are having three things. We are having three things. Umar, ring means internal meshing. You are correct. So my dear, concept of just wait guys, just wait. Yes guys, concept of fixing torque. So when we are talking about fixing torque, there are three things. One is sun, arm and planet. Okay, you are having sun gear to be fixed. You are having sun gear to be fixed. This is the planet. This is the arm. So you know that my dear, as the axis of planet is always rotating, even you can have a ring gear like this. So you know that axis of planet is always rotating. Ring also added. Axis of planet is always rotating. So as the axis of planet is always rotating, we cannot directly give any torque to the planet. Whatever the torque we will be giving either to the sun or to the arm or to the ring, which are having fixed axis of rotation. Okay, so I can write T of input, T of output, T of input plus T of output plus T of fix. Why I am saying fix? You know that one gear is kept fixed. Either they will say ring gear is fixed or they will say sun gear is fixed. So they generally give one gear as fixed. So Ti plus To plus Tf is equals to 0 because we are assuming the system to be isolated. This is the one equation. And the second equation is summation of power is going to be 0. That is Ti omega I, To omega O plus Tf. You know that fixing torque means the gear which is fixed, for that omega is going to be 0. If omega is 0, this term will be 0. So you can have Ti omega I plus To omega O is equals to 0. So you can see these are the two equations 1 and 2. So always Ti is given to us. So we can find out T naught and fixing torque. They can be found out. And guys, in this week, you will also be having a daily dose session on the same thing. Daily dose session will be coming on the same. Yes, Anshu, what happens? Yes. Moving to the next topic, kinematic and dynamic analysis of single slider crank mechanism. Okay, so when you see this, my dear, you already remember we have derived some formulas for that. You know, here R is the crank radius. I am telling you all the dimension, then I will show you the formula. This is the R, this is the L, this angle is theta, this angle is beta. You know that this is the common side. Okay, so you can write this as R sin theta is equals to L sin beta. Is it clear? So my dear, you will be using this, and when you will be using this, you know, this is L sin beta, this is R sin theta, and if you are talking about this is the R crank radius, L is the connecting rod length, then my dear, N is defined as the oblique ratio L by R, and it is very, very big than 1 as compared to 1 if you see for the Sir James Watt engine. Yes, very good guys, very good. So we have defined some formulas. First formula is for displacement of the piston. So displacement of the piston is given by this: x is equals to R into 1 minus cos theta plus N minus N square minus sin square theta. Then my dear, velocity, when you will be differentiating it, you will get this. This is approximation. This is the approximation when we are assuming N is very, very big. Okay. Then my dear, acceleration of piston is given as A is equals to R omega square then cos theta plus cos 2 theta divided by N. You will be having acceleration to be maximum when theta is going to be 0. To find out the velocity to be maximum, you need to differentiate it, dv by dt to be equals to 0. Okay, so that value will be definitely affected by the value of N. Okay, but if N value is not known to us, for that case you can keep theta to be 90 degree. Okay, for finding out the maximum velocity. If you want to see the forces on piston, this is the kinematic analysis. That would be coming in the dynamic analysis, Umar. Okay, then my dear, omega connecting rod is given as omega cos theta divided by N. And alpha of connecting rod is minus omega square N by sin theta. You know that these we have derived also in the marathon, but this is the revision session. Now let us see the dynamic force. So you know that already when we are talking about the cylinder, so you are having the steam engine. In the steam engine, when we are having the piston, then piston was facing pressure because of the steam at this side and also pressure at the steam on the other side. This steam is high enthalpy, this is low enthalpy. So this pressure is more, this pressure is less. So we are having P1A1 minus P2A2. This is the gas force. We would be having the inertia force equals to this. We will be having, what is inertia force? You know that by Newton's first law of motion, if a body is in motion, it will try to continue in the motion. If a body is at rest, it wants to be in rest. So everybody wants to be in its state of motion. So if that is the case, when piston is coming from this position, it was at rest. So when, my dear, you are moving the piston, obviously you are changing the state of motion, for which piston will show some resistance, and that resistance is said to be the inertia force. And that resistance will always oppose it. So you know, from this position to the center of the cylinder, velocity will increase from 0 to maximum. So because of that, inertia force will be acting in this direction. After that, velocity will be reducing to 0, and because of this, inertia force will act in this way. So that is why we are doing the analysis only for half of the stroke, because for rest half the direction of inertia force will change. Okay, so when you will try to increase the speed, it will resist the increase. When you will try to reduce the speed, it will resist the change once again. It always opposes the change you are going to do. Okay, velocity and acceleration of piston, most important. Okay, thanks Kalyan for that. Okay, so this is the inertia force, and friction will be acting also, but generally it is not given, but if it is given, friction will always oppose the relative motion, and gravitational force will be coming only for the vertical engine. For horizontal engine, it will not come. So when you will see the net force will be coming out to be gas force minus inertia plus minus friction plus minus mg. You already know that. Why friction is plus minus? Because friction will depend on the tendency of motion. Okay, tendency of relative motion. Mg will be depending on vertical engine, whether you are having piston upward. If piston is upward, mg will be acting in the direction of motion. If piston is downward, then mg will be acting opposite to the direction of motion. So that is why here we have plus minus. Everybody got it? Please tell me, guys. Do like and share the session, guys. We are moving fastly now. So if you will see the connecting rod force, the connecting rod force is given as F by cos beta. Here F is the net force on the piston. Then you can see the normal thrust force on the cylinder walls. Like if you see the cylinder like this, if you have the piston like this. So this is the thrust force. This is the connecting rod force. This is FCR, this is Fn. So this is given as F tangent beta. Very good Sanket, बहुत ही बढ़िया. Then we are having radial thrust. You know that there is a radial force because when this is connecting rod, this is crank. So my dear, this angle was beta and this angle was theta. So if you see connecting rod force is going like this. Connecting rod force is going like this. We are having this to be the crank. Then my dear, one component will be perpendicular to this. Okay. One is coming in this direction. This is said to be radial force. This is said to be tangential force. To find out the angle, you know this angle is theta, this is beta. So we will be having Ft to be sine theta plus beta, Ft to be sine theta plus beta, Fr to be cos theta plus beta. Actually, I am writing Fr to be the connecting rod force into Fr to be the connecting rod force. This angle is cos theta plus beta. But we have just seen what is FCR, that is F net by cos beta into cos theta plus beta. Similarly, we have F tangential. Yes, guys. Similarly, we have F tangential. So F tangential is given as F cos beta into sine theta plus beta. Torque will be tangential force into radius. Okay, and you can see this torque can also be written as I into alpha. So you know that theta and beta are the function of time. So definitely alpha is a function of time. When alpha changes with the time, jerks are coming. So we need some instantaneous fluctuation control devices. They are flywheel and governor. So straight away moving to the flywheel. This is the turning moment diagram. You know that work done in the cycle is defined as, you can see the time period is from 0 to 2 pi for double acting steam engine. So you will integrate from 0 to 2 pi T d theta. And you can also write in the form of mean torque, T mean into 2 pi. So mean torque will be defined like this. So you can say mean torque is that constant value of torque which if remain throughout the cycle will give the same amount of work done as given by the engine with the variable torque. Okay. So my dear, without flywheel, engine is giving us this. By using flywheel, we expect this. But in reality, flywheel will provide us this. Means flywheel will reduce the vibration, reduce the effect. Thanks. Yes, Ajay. So that is required now, because already in the marathon I have taught you that in a great detail. 16 hours marathon was not there for any subject. Even for production it was not happened. So you can see 16 hours I have given for tone and vibration. So right now I think now you can move ahead with a very fast speed. So my dear, for 4-stroke IC engine it would be work done in cycle by 4 pi. So you can write it as 1 upon 4 pi integration 0 to 4 pi T d theta. Okay, then I feel you are also aware of the fluctuations of speed. Maximum fluctuation of speed is given by n max minus n minimum. Then coefficient of fluctuation of speed, CS, can be defined as n maximum, n minimum by n mean. N mean is defined as maximum plus minimum by 2. Okay. Then my dear, you also know that the maximum fluctuation of energy is E max minus E min. E max is I omega max ka square. E minimum I omega min ka square. Okay. So you can write it in this way and we will get the fundamental equation of flywheel from which all the numericals are coming. That is delta E is equals to I omega mean ka square CS. And you can also define delta E by work done in a cycle as coefficient of fluctuation of energy. If you see the relation between CE and CS, that is coming like this, but you will never be using that in the question. That is only if they ask relation you can use it. You also know if you need to find out the ratio of omega max by omega min. For that we derived the expression 2 plus CF by 2 minus CF. That also have been asked in GATE 2006 for 2 marks. Yes, coefficient of steadiness is 1 by CS. 1 by CS is coefficient of steadiness. Very good, guys. I feel everybody is getting it. Yes. So do like and share the session, guys. Then you know moment of inertia. Moment of inertia of rim or ring is given as mr square. And moment of inertia of disc is given as mr square by 2. I feel everybody got it. Then my dear, you know the design of flywheel that was saying that speed is restricted to a value of sigma by rho. So because of that, ring type of flywheel, because for ring type of flywheel, when you say V maximum, it is R into omega. So for ring type of flywheel, complete mass is at the outside. So for ring type of flywheel, R is maximum. So omega will be minimum. So that is why it can be used only up to 1200 RPM. Then we have disc type of flywheel. Disc type of flywheel, for that, you know the mass is coming towards the center because disc is like this. Mass is coming towards the center. So if you see the center of mass, that will be shifting to downward. Previously it was at entire R, now it is coming downward. So as R is getting reduced, omega can be increased. So disc type of flywheel can be used for high speed application. Even for lakhs of speed we can use it. Even for lakhs of speed we can use it. Everybody is clear or not? Please tell me that. Everybody is clear or not? Please tell me that. Moving further to the governors. Flywheel. I said dear, the number of formulas are very less in TOM. I always say TOM is a fundamental subject. All the formulas are derived using trigonometry. Okay. So there are no those genuine formulas which are there in production to remember. Okay. Yes. What is rho in this Vmax? Dear, this rho is density of material. Sigma is permissible stress. Got it? Got it, Ajay? Now we are talking about the watt governor. So you know that for watt governor, if you are going to find out the equilibrium equation, you will be getting H is equals to G by omega square or 895 by N square. You can also write it as H 895 by N square. So as you can see, N square is coming in denominator. So my dear, when the speed increases beyond 60 RPM, when speed increases beyond 60 RPM, then this governor becomes insensitive. Why? Because for that case, denominator is very, very high. So change of height will be very, very less. So my dear, for such cases, your governor will become insensitive. So guys, I am not going into that detail. In the marathon, I have taught you why governor is required, what are partially governed system, what are completely governed system. I told you there for the first time how Sir James Watt have given this concept. What is R, what is H, that you already know. This is formula revision series. So it is something you already know. I am just going for a revision. Okay. So that is why this is for the Watt governor. Then you know there was an improvement in the Porter governor, where we are going to give an extra weight to the sleeve. So if you find any difficulty, if you have any doubt, do ask. I will explain it for sure. Okay. So Porter governor, when we are saying the Porter governor, what Porter have done? Porter have kept a very heavy mass onto the sleeve, and by adding that mass, the equation of dynamic equilibrium changed to this. You can see n square is 895 by h 2 mg, mg plus minus f. This f denotes the friction. K is defined as tangent beta by tangent theta, where theta is this angle and beta, you know that beta is this angle. This angle is beta. Okay, and you can see that, my dear, if K is given to be 1, when beta and theta are becoming equal, then tangent beta, tangent theta will become equal, it will become 1, then the equation will reduce to this. When they say friction is also 0, then this equation will reduce to this. If friction is also 0, K is also 1, then we are getting this equation. So this is the smallest form of the equation, and you can see this time you are getting a very big term, because capital M should be very, very big as compared to small m. Small m is the mass of fly ball and capital M is the mass of sleeve, because this mass is something which is creating the difference. This is something which is making the governor to be sensitive. Okay, विनीत याद तो रखनी पड़ेगी, but if you will be writing it 2 to 3 times, you will very easily remembering it. If you remember, I have derived it in front of you, so if I can derive, you can definitely. Okay, is it clear? So I don't feel it is going to be anything difficult. Okay, so still I would like to say the chances of question from these equations are very, very less, but still it can come. That's the point. Okay, so my dear, this is going to be the case. Okay, these are the cases I have considered. So when we are going to see this Porter governor, this was working well. This was the first working governor. Watt governor was not a working governor. This was the first governor which was working with the engines. That is the point. Okay, that is why it was given preferences, but dear, it was having very large inertia because of the sleeve. So that's why another person came, that is Proel. He wanted to reduce this inertia, and because of that he have kept the fly balls to be in this position. And when he have kept fly ball to be in this position, we reached to a point that now whatever the mass of fly ball, that can be reduced, because he have multiplied it with the factor of A by E, where if you see the E value, this was the E value. So E value was a very, very big value. So initially Watt have given us an equation which says H is equals to 895 by n square. We were having problem with this n square. So Porter have helped us by multiplying it with some quantity, and that quantity was 2 mg plus minus fs divided by 2 mg into 1 plus k. Porter have done this for us because Porter wanted to make this term bigger than 1, so that overall we get a big term for H. But once again Proel have multiplied it by A by E, where E is bigger. So this term is once again taking us towards the Watt governor. So my dear, if we want to make a superior governor, if not superior, we have to give at least the same performances as given by Sir Porter's governor. So for that purpose, what we reached on to? We reached on to that if you want to make this factor to be at least it should not affect it, at least it shall give the performance of the Porter governor. For that we need to reduce this denominator, or we need to increase this numerator. Increasing numerator will further increase this capital M. So we have chosen reduction of small m. So in Proel governor we have reduced the mass of the fly ball, and by doing that we were getting the same performances as given by Porter governor with slightly small fly ball. I would like to say those students who want some in depth of these equations, then go for the theory of machines marathon part 2. There I have derived all these things. This session is for formula revision, so I am not deriving them, I am directly giving you the formulas. Then if you see the Hartnell governor, for Hartnell governor this was the formula for the spring force, and here the important formula is related to the that FS2. What is FS2? They are the spring forces. So Fs2 and Fs1, they are the spring force. You can write it in this way. Fs2 can be written as S delta 2 minus S delta 1. Then 2a by b. What is F2? F2 is mr2 omega 2 square. F1 is mr1 omega 1 square. F1 is mr1 omega 1 square. So this will give you the S delta 2 minus delta 1, where delta 2 minus delta 1 is nothing but the sleeve movement. If sleeve movement is given to you, you can find out stiffness, and if stiffness is given to you, you can find out the sleeve movement. Very good, guys. So this is how you can use this equation. Now we are coming on to the characteristics of governor. The first characteristic was sensitivity. So sensitivity is defined as delta n upon n mean. This is the sensitivity. And there is something coefficient of insensitiveness, that is given as n mean by delta n. Okay. Then my dear, for what governor, when you see the coefficient of insensitiveness due to friction, for what governor it is friction force by mg. For Porter governor it is friction by m plus mg. For Hartnell it is F friction by spring force. And power of governor is having this formula. That also you need to remember. This is actually telling us the work done. Work done in movement of sleeve. Work done in movement of sleeve is said to be the power of governor. This is the formula for that. I feel everybody got this formula. Moving to the balancing part. Moving to the balancing part. When we are talking about the balancing, you already know that. For that you can write MB. This is the balance mass, balance radius. MB into RB cos theta b can be written as minus summation I is 1 to n MI RI cos theta I. Then you know MB RB sin theta b minus I is equals to 1 to n MI RI sin theta I. If you want to find out the product of MB RB, you just need to square and add. You will be getting the equation like this. It is summation MI RI cos theta I का square plus MI RI sin theta I का square. I also told you one thing, my dear, that out of MB and RB, you must be knowing one thing. If you don't know even one of them, you cannot find out the second one. Is it clear? I feel everybody is getting it properly. This is said to be the balancing. So we have done it before. Now we are going for this also we have seen. Then if you want to find out the angle of the balance mass, then that is the formula. But my dear, never cancel these minus signs, because these minus signs will decide the final quadrant of the balance mass. Okay, how they will decide? If you are going to have y to be minus 4, x to be plus 3, then this minus will make minus 4 to be plus, and this minus will make 3 to be minus. So we are going to have plus 4 by minus 3. It shows y positive, x negative. Y is positive, x is negative in the second quadrant. So in reality, the balance mass will be coming in the second quadrant. But if you cancel these minus sign, then you will be having the ratio to be minus 4 by plus 3, which is showing fourth quadrant. Okay. So that is why if you are cancelling the minus sign, then the quadrant of balance mass will be coming just opposite, which will just double the unbalancing. Okay. Okay. Kalyan, I am writing it with the yellow color. That would be more visible. Is it clear now? So moving further for the reciprocating balancing. You know that in reciprocating, we have divided the unbalanced force into two things, into two parts. One part was the primary force, other was the secondary force. Primary force is given as mr omega square cos theta. Secondary is mr omega square cos 2 theta divided by n. Is it clear? Primary is quite bigger than that of secondary. Sir, have you also included formula for flywheel in punching? Dear, for punching machine, their formula is same. Okay. So that is only one thing is there, that is delta theta by 2 pi. That I have not written. If you want, I can write it. So don't worry, dear. I am writing. Kalyan, I am writing. Whatever I have written, that is the thing which is written in the white box. Okay. So no need to see the white box. I am showing you. I am writing. Okay. So like you are asking for Ajay, I am writing one thing. For Ajay, I am writing one thing. If you want to go for flywheel in punching press, then delta theta divided by 2 pi. That is energy given in punching time, energy given in cycle time. Time for punching, time for cycle. That is distance traveled during punching is P. Distance during cycle is 2 times length of stroke. It can also be written as distance in punching, length of stroke can be written as 2 times of R. So these ratios were coming out to be equals. Rest the formula is same, delta E is I omega square CS. So in the formula, I am writing only the formulas. The techniques we have already discussed in the marathon session. Okay. Wonderful, guys. Wonderful, guys. So now, my dear, I am talking about the resultant force. When we are going for the partial balancing, then my dear, primary unbalanced force will be mr omega square minus cmr omega square. So you will be getting, this is the primary force in x direction, 1 minus c mr omega square. Primary force in x direction. Okay, this will also be having cos theta. Cos theta. Then primary force in y direction, cmr omega square sin theta. Because when we are going for partial balancing, we are having two components. Manas is saying, can we expect question on radial engine balancing? aa to sakta hai Manas, it can come, but till now there is no question. So it can come, but till now there is no. That's why I taught you that, but it is generally not taught anywhere else, but I will not say to leave it. It can come in the exam. Okay. So this is FPX, this is FPY. So if you want to take the resultant of this, no need to see in the white box. I am writing the formula. It is 1 minus c mr omega square cos theta ka square. Because both these forces are perpendicular to each other. Cmr omega square sin theta. This is the case. Everyone is clear about this? This is the case of partial balancing. For partial balancing, we are getting many side effects. Tractive forces. We are getting variation in tractive forces like this. So we are getting minimum and maximum value of tractive force like this. Plus root 2 to minus root 2 mr omega square. Is it clear for everyone? Then we will be having the swaying couple. Swaying couple is coming out to be, it is 1 by root 2. 1 minus c mr omega square into a. Here a is the distance between the cylinders. Yes, thanks Deepak for your wonderful words. Moving further, guys. Then you know hammer blow. Hammer blow is given as mb rb omega square. This is said to be the hammer blow. So guys, moving further, secondary balancing also, I already told you, when we are doing this, we are writing it as mr 2 omega ka square cos 2 theta by 4n. So this will help you. Why? Because we are assuming a crank of r by 4n size rotating with a speed of 2 omega for the balancing purpose. Is it clear? Yes. So this is something called as the secondary balancing part. So my dear, this we have already discussed primary and secondary. Now we are entering into the cams. Yes. So my dear, when we are talking about the cams, for that there are not much formulas. You have seen how we are going to define the terminology. If this is the cam, you know that if this is the cam, then my dear, if this is the follower, then I will be asking you now, if I take this center as center and I make a circle which is tangent to the cam profile, then this white circle will be said to be base circle. Okay. Then my dear, if you are going to take this point as trace point and draw the profile after rotation of this follower around the cam, this is said to be pitch curve. Similar to this base circle, tangent to pitch curve is prime circle. Okay. Then you know that this radius of prime circle minus radius of base circle is radius of roller. Got it? Deepak, as I said, we cannot say that question will not come from cam. Yes, possibility is lesser relatively, but questions may come from cam. So I would like to say you go only with the types of motion. Types of motions are very important in cams. Okay. So then my dear, we are moving, you know that the first derivative, second derivative, third derivative, out of this derivative is dangerous. Okay. So you know that displacement should be lesser, jerk should be lesser, but it must be lesser, because if acceleration is bigger, contact of cam and follower may break, or follower may undercut the cam, and it may result into interference and undercutting phenomena for the cam. Okay. Yes. Then we are moving further, guys. You know that for uniform velocity motion, velocity is given as, it is s omega by phi naught. So I have chosen this coordinate at that time for uniform velocity, and the maximum velocity for uniform accelerated motion is 2s omega by phi naught. These are the formula we derived in the marathon. Okay. So my dear, for SHM, the maximum velocity is given as h pi omega by 2 phi naught. Phi naught is the angle of outstroke. Okay. If you want to write down the maximum acceleration angular, it is h by 2 pi omega by phi naught ka square. These are the formula for SHM. All these motions we have discussed at that time. Right now we are just going with the formulas. So maximum acceleration can be written as 2h pi omega square by phi naught ka square. Guys, is it clear now? Because if I will be going for these motions again, then there is no difference in that marathon and this marathon. This is just revision of formulas. Moving further, this is for cycloidal. Okay, this is for cycloidal motion. Then moving to gyroscopic effect. Everybody remember, for gyroscopic effect, the formula was I omega omega p. This is the only formula where I is given as mk square. If you are studying about the pitching, then for pitching, theta can be written as pi sine omega t. Okay, this is the formula for pitching, because when pitching happens by some angle of theta, then that is defined like phi sine omega t, because it is also following some sine harmonic function curve. Okay, wonderful guys, बहुत ही बढ़िया. Then my dear, I feel okay, that is not required. Okay, that is for natural frequency now. For natural frequency means we are reaching to vibration. You know, this is the governing equation of natural vibration system. And for this, omega n is given as square root of s by m. Fn in hertz it is given as 1 by 2 pi into s by m. Time period is given as 2 pi by omega. It is 1 upon f. I feel everybody got it. This was the formula for natural vibrations. Then my dear, energy method was saying that total energy of the system is kinetic energy plus potential energy. Kinetic energy will be coming because of mass, potential energy due to stiffness. Then you will say dE by dt to be 0. You are conserving the energy of the system. So this method is valid only for natural vibration systems. Then in relay method, if you remember, relay method says you just need to find out the static deflection of mass. You need not to derive any governing equation, and you can directly write the natural frequency of vibration to be g by delta naught. This is said to be the relay method. This is also valid only and only for natural vibration systems. Then my dear, if the spring is not massless, then natural frequency will be coming out to be stiffness divided by m plus ms by 3. Here ms is the mass of spring. Here ms is the mass of spring. Ms is the mass of spring. Then my dear, this is for torsional vibration. Like for torsional vibration, the stiffness is written as T by theta. So for this, natural frequency will be coming out to be square root of Kt is the stiffness of torsional vibration, K theta. This is I of rotor plus I of rotor plus I of shaft by 3. Similar to the previous case, it is going to be I of mass by 3, I of shaft by 3. Okay. This is for damped vibration system, my dear. This is for damped vibration system. For that I am writing the formula, don't worry. If you remember the damping factor is C by 2m omega n. It is C by 2 root mk. 2 root mk. Then my dear, you can also write zeta square as the degree of dampness. Zeta square as degree of dampness. And my dear, if you see this damping factor, C by 2 root mk is the damping factor, and you can also write it as C by cc. So coefficient of critical damping, if you see, that is 2 root mk. These are the formula which are generally coming for damped vibration system. Very good, guys. Then we have a formula for zeta to be C by cc. We also know that damped frequency as natural frequency into 1 minus zeta ka square. This is also one of the formula. Okay. Then after that, we are going to have the logarithmic decremental ratio. Delta is 2 pi zeta divided by square root of 1 minus zeta ka square. And decremental ratio is defined as x naught by x1 or x1 by x2. All these ratios are equal. They are xn minus 1 by xn, and that is e to the power zeta omega n td. I feel everybody got it. Okay. Yes. Then my dear, we are going to have force damped vibration system. For that we have 3 formulas. Amplitude is f naught by s divided by 1 minus r square ka square plus 2 zeta r ka whole square. Here r is omega by omega n. You know, then magnification factor is 1 divided by 1 minus r square ka square plus 2 zeta r ka whole square. Then we have transmissibility ratio. It is coming out to be 1 plus 2 zeta r ka whole square by square root of 1 minus r square ka square plus 2 zeta r ka whole square. Everybody got it? So these were the formulas. And my dear, with that we have completed this vibrations also, and we have covered all the formulas. So don't worry, I will share this PDF, and those white, if you are facing any difficulty, I have written all the formulas, but still when you will see the PDF, you will be able to see these formulas also. Don't worry about that. And guys, with this we have completed the theory of machines, Formula 1. Before leaving, just like and share the session, and tomorrow morning 10 a.m. we are meeting for material science marathon. Okay, and within 3 hours we will try to complete it. And tomorrow I will be asking you in the class whether you want metal forming marathon. If you guys will ready, I will take that on Tuesday. Okay, and we will complete the marathon series in that way. And tonight we will be having theory of machines 10 practice question. Like today we have seen for production, tomorrow we will see for theory of machines. Thanks Deepak, thanks for your wonderful words, thanks for that. So guys, goodbye for this session. Thanks for joining. We will meet tomorrow morning 10 a.m. Even if you have not seen material science, then tomorrow's session will help you to score if simple questions comes, even if difficult question comes to some extent. Goodbye guys, good night.